All right, so let's proceed. Let's take a look at the third quadrant. So what we have is we have in this third quadrant, the only thing that we have positive is tangent. In this quadrant, tangent is positive. All right, so now we're looking at a 210 degree angle, another obtuse angle. Don't use the obtuse angle to calculate this. Use the reference angle of the 210. In other words, the acute angle measure from this angle to the x-axis. We're calling that the reference angle. And in this case, it's 30 degrees. So again, we've already determined what the cosine of 30 degrees is. That was radical 3 over 2. Radical 3 over 2. The sine of 30, we've already determined is half. And the tangent of 30, we've already determined is 1 over radical 3. So now all you're going to do is just remember that tangent is positive. So now the tangent of 210, that's positive, but the sine of 210 is negative half. The cosine of 210 is negative radical 3 over 2. All right, so let's keep going. Here we've got 225. The reference angle is 45. The number acute angles from the x-axis, 45. We've already determined that the cosine of 45 is 1 over radical 2. The sine of 45 that's also 1 over radical 2. And the tangent of 45, that is 1. All right, that is 1. So tangent is positive, but the sine of 225 is negative, and the cosine of 225, that is also negative. All right, so 240, the reference angle is 60. The acute angle measured against the x-axis is 60 degrees. We've already determined that the cosine of 60 is half. The sine of 60 is radical 3 over 2. The tangent of 60 is radical 3. All right. So the tangent of 240, that's positive. The sine of 240 is negative, and the cosine of 240, that's negative. All right, so we got one more degree measure. One more degree measure, and that is the 270 for this quadrant, 270. So on the unit circle, if this is 1 unit, if that's 1 unit, this would be the point 0, negative 1. 0, negative 1. The cosine of 270 is 0. The sine of 270 is negative 1. The tangent of 270, we've already talked about this. Tangent of an angle is sine of the angle over the cosine of the angle. So the sine of 270 is negative 1 divided by the cosine of 270, which is 0. You'd end up with a denominator of 0, which is undefined. All right, here we go. Undefined. So the reference angle is 60. The reference angle here is 60. So the cosine of 60, is half. The sine of 60 is radical 3 over 2. The tangent of 60 is radical 3. Now you have to recall that in this quadrant, the cosine is positive. So the cosine of 300, that's positive, but the sine of 300, that's negative, and the tangent of 300, that's negative. All right, so let's keep going. Let's go to 315. The reference angle of this 315, the acute angle measured against the x-axis is 45. So don't use the cosine of 315. Use the cosine of the reference angle of 315, which is the cosine of 45, which we've already previously established as 1 over radical 2. The sine of 45, that's 1 over radical 2. The tangent of 45, that's 1. Remembering that in this quadrant, cosine is positive. So that's positive. The sine is negative. The tangent is negative. The cosine of 315 is a positive 1 over radical 2. The sine of 315 is negative 1 over radical 2. The tangent of 315 is negative. All right. So let's keep going. We've got this angle here, 330 degrees. 330 degrees. The reference angle of 330 is 30. So what you have to do is don't use the cosine of 330. Use the cosine of the reference angle of 330. Use the cosine of 30 degrees. Don't try to determine what the sine of 330 degrees is. Use the sine of the reference angle of 330, which is 30. So let's go by doing that. The cosine of 330 is radical 3 over 2. The sine of 330, or the sine of 30, is 1/2, and the tangent of 30 is 1 over radical 3. But you have to remember that in this quadrant, cosine is positive. So this is positive, sine is negative, the tangent is negative. So we've completed the entire unit circle. We've completed the entire unit circle. And what I want you to be able to see is the beauty of this now is you've got a one-stop place where all of your trig ratios are available to you, at least the most common ones coming from the special triangle. The most common trig ratios are right before you. So now you need to know what the cosine of 120 is. You know it's -1/2 without really thinking about it. You want to know what the sine of 210 is. 210, the sine of 210, it's -1/2. You have everything at your disposal right here. I'd like to now talk about where these radian measures came from. This pi over 3, this pi over 2. I want you to be able to see that another way of saying 90 in degrees, 90 degrees, is pi over 2 radians. Pi over 2 radians. All right. So what you can do to convert from one to the other, if you have 90 degrees, you can multiply by pi over 180, which is how you convert from a degree measure to a radian measure. Notice how there's cancellation there. That becomes a 1. That's divisible by 90. This is divisible by 90. You end up with pi over 2. So what you've just done is you've just converted from a degree measure to a radian measure. This is the same amount of angle. It's just another way of saying it. It's almost like a different language. The degree measure is the unit of measure that you're most familiar with in everyday life. But radian is more of a mathematical way of identifying a 90-degree angle, very common in higher level mathematics using radians as opposed to degrees. All right, so another thing that we'd like you to be able to see is if you were converting from, let's say, something like 300 degrees, converting 300 degrees into radians. All right, so another way to say 300 degrees, again, is to multiply by pi over 180. And what you can see here is that each of these are divisible by 30. Each of these are divisible by 30. Actually, each are divisible by 60. All right, if you divide this by 60, you get 5. You divide that by 60, you get 3. So you end up with 5 pi over 3. So another way to say, hopefully you can see that, another way to say 300 degrees is 5 pi over 3. It's the same angle, but it's a different way of saying it. Let's convert from radians back to degrees. Here I'm converting from degrees to radians. 300 degrees is the same thing as 5 pi over 3 radians. Let's also convert from radians to degrees. Let's say you don't know what 4 pi over 3 is equal to. Let's say you have 4 pi over 3, and let's say you want to convert that into degrees. What you're supposed to do here is, instead of multiplying by pi over 180, here you'd multiply by 180 over pi. That's when converting from radians to degrees. The pi's cancel. This 3 cancels with the 180. You get 60, and you end up with 4 times 60, which is 240 degrees. So another way to say 4 pi over 3 radians is 240 degrees.